3.1 Intro to Chemical Bonds. So we have a lot of stuff to go over here. First off, why do atoms bond in the first place? Okay, so why do atoms bond? Here's what happens. Bonds result from the attraction of nuclei for electrons. So the nuclei is the nucleus. The nucleus craves these electrons because remember the nucleus is positive and these electrons are negative. So the nucleus wants to have a certain amount of electrons in order to be stable. Okay, so all atoms want to achieve a stable octet. Okay, all atoms want to achieve what's called a stable octet. They do this by either gaining, losing, or sharing electrons. Okay, so a stable octet is gotten by either gaining, losing, or sharing electrons. The valence electrons determine the chemical interactions between atoms. Okay, valence electrons, right there. Valence electrons determines the chemical interactions. So the number of valence electrons determines how reactive an atom is. One thing about this, a stable octet, that prefix octet means 8, right? Prefix oct means 8. In most cases, most atoms want 8 valence electrons. So they do this by either gaining, so if they have 6 valence electrons, they'll gain 2. If they have only 2, but they have 8 underneath, they're going to get rid of those 2. Sharing, so let's say some guy has 4 and they've got 4 and they only need 2 each, they kind of share to make sure that they get what they need. Okay? This table, you need to take a quick second and draw it. You need to make it pretty much a whole page. We're going to fill it in as we go through this video. Okay? At the top are the 3 types of bonds. So you have metallic, ionic, and covalent. We're going to go through what it bonds between, so like metals, nonmetals, and so forth. What causes the attraction, so why is there a bond there? Key phrases that you need to look for in a problem and their properties. So let's talk about metallic first. Metallic, bonds between. This should be obvious because it's metallic. It is between a metal and a metal. A metal and a metal. Why do these metals have any kind of attraction towards each other? It's because the valence electrons are mobile or mobile. And metals are become positive ions. So those negative electrons are attracted to the positive ions that the metals make. Key phrases, one is already up in there. Mobile electrons, that's a key phrase. Another one, sea of electrons. So like the electrons are literally like fish in the ocean. The electrons are sort of flowing through all these positive ions. And then a big word here that they like to use sometimes is delocalized, which means that they're not staying local. They are moving throughout. Key properties, the properties of a metallic bond is the exact same properties of a metal. So if you remember that from previous, then you should still know it. They have high boiling points and melting points. Good conductors. Malleable and ductile. Okay, remember those 2 words pretty much means it can be hit or shaped to form certain shapes that you need. Okay, that is metallic. Ionic and covalent, we're going to talk about them now, and then we're literally going to spend like a day or 2 on each of them afterwards about even more stuff. Ionic, key phrase there is going to be ion. It's all because they form these ions, and what happens is you have to have a metal and a non-metal, or a cation and an anion. Okay, we talked about that in unit 2 or something like that. Okay, so it's a metal and a non-metal. The attraction is because you get the opposites attract. Opposites attract. You get this cation which is positive, and it's attracted to the anion that is negative. So you get this attraction between the two. Key phrases, you need to make sure that you know they transfer electrons. That's what's happening with their electrons. The cation is giving them to the anion. So the cation becomes positive, the anion is negative. Properties. Now here's the thing with ionic. It's got this metal sitting in there, but it also has this non-metal, so you get this weird combination of properties. They still have high melting point and boiling points. They form crystal structures or crystalline structures when they're solid. And good conductors, but here's a catch thing here. They're only good conductors in liquid state, meaning they're either melted down or they're dissolved in water. So they're only good conductors in liquid state. Metals, good conductors always. Ionic, only in liquid state. Covalent, last combination is going to be non-metal and non-metal. Covalent is because they are sharing electrons. That's why they form this bond, because they're sharing electrons. One non-metal is giving to another. They're kind of going back and forth, kind of like tug of war. Okay. Key phrase is what's already there. Okay. Caring is sharing. Caring, C, caring, covalent. Covalent is sharing, caring is sharing. Now, properties, again, just like your metals, metallic has the same properties of metal. Covalent are non-metal, so they're going to have the exact same properties as non-metal. So they're going to have low melting point and boiling point. Poor conductors, just like your non-metals, nothing's changed here. I'm going to abbreviate, sorry. And they are brittle in solid state.